Dear colleagues, let me welcome you. I'm very glad that I have the opportunity to speak at this conference. My name is Yuri Gapanyuk. I am from the Informatics and Control Systems Department of Bauman Moscow State Technical University. Our work is dedicated to the information system for advertising video generation based on machine learning approach. The outline of our presentation is as follows. First, we will talk about the purpose of the developed system. Then we will describe the developed system as a hybrid intelligent information system, or HIIS. Then we will consider the system operation. We will discuss the generalized process of system operation and main system models. The model for obtaining the characteristics of the FRUCT profile, the user photo processing model, the posts analysis model, the photo analysis model, the video creation model. In conclusion, we will summarize the main results. The purpose of the developed system is to generate a custom video for a particular user using information from his or her social profile. This is done to encourage users to use a particular product. One of the key components is an analysis of the user's profile picture because it had to be used directly in a publicly available video. So a photo has been passed through a set of filters and transformers to be included in the resulting video. Also, an extensive profile analysis has been performed to determine the personality of user accurately. Problems that have been solved in the developed system include face recognition, head pose detection, inappropriate content filtering, sentiment analysis, and object detection in photos. Despite the fact that a large number of publications in the field of marketing are devoted to video advertising, we couldn't find publications that would discuss in detail the technical aspects of video advertising systems being developed. Therefore, to develop the architecture of the system, we used the architectural framework developed at our department, the Hybrid Intelligent Information Systems, or HIIS approach. A HIIS should combine the elements of the system based on soft computing and conventional information system based on data and knowledge processing. The generalized HIIS architecture includes the following components: the environment, or ENV, the subconsciousness model, or MS, the consciousness model, or MC, the boundary model of consciousness and subconsciousness, or bound, and the model of interaction, or MI. The subconsciousness model is related to the environment in which a HIIS operates. Because the environment can be represented as a set of continuous signals, the data processing techniques, or the MS, are mostly based on neural networks, fuzzy logic, and combined neurofuzzy methods. The consciousness model is based on conventional data and knowledge processing, which may be based on traditional programming, workflow, or rule-based approach. The boundary model of consciousness and subconsciousness is intended for deep integration of models of consciousness and subconsciousness and represents an interface between these models with the function of data storage. The data is a complex ontology that is used by both the consciousness and subconsciousness models. The main task of the subconsciousness model is to recognize elements of ontology from the environment. If we consider the consciousness model as a kind of expert system, then the recognized elements of the ontology can be considered as elements of the operating memory of the expert system that trigger the corresponding rules. Depending on the goals of the system, rules can generate output information for the user or signals for a subconsciousness model that have the desired effect on the environment. The model of interaction is used for the interaction with another hybrid intelligent information systems. The proposed HIS concept is considered as a general approach or generalized architectural framework that should be adapted to create information systems in specific subject areas. The architectures of the proposed system based on the HIS concept is presented in the next slide. A feature of the environment in the developed system is that the environment is a heterogeneous source: texts, images, data from the social network. The current implementation of the system uses only the FRUCT social network. The subconsciousness of the system is a set of models based on machine learning models and designed to extract the necessary data from the environment. Some of this data is used to verify user information and some to form the final video. The boundary model of consciousness or subconsciousness is implemented as an in-memory storage, intended both for intermediate storage of output results of models included in the system's subconsciousness, and for storing processed data used for video generation. The system's consciousness model reads from the storage the output data of the models included in the subconsciousness of the system, processes the data, and writes into the storage the processed data used to form the video. The generalized process of the developed system operation is shown as a sequence of steps that perform semantic enrichment of the resulting data. The primary dialogue includes initial communication with the user and the choice of the contactor profile for analysis. After calling the model for obtaining the characteristics of the contactor profile, the profile characteristics are added to the resulting metavertex. After calling the user photo processing model, the user photo processed and ready for including into the video is added to the resulting metavertex. After calling the post-analysis model, the extracted from the text user psychological characteristics are added to the resulting metavertex. After calling the photo analysis model, the extracted from photos user psychological characteristics are added to the resulting metavertex. The collected data is processed and aggregated for video creation purposes. After calling the video creation model, the generated video is sent to the user. The data processing details are described in the following slides. The model for obtaining the characteristics of the contactor profile. The primary purpose of this relatively simple model is to extract attributes from the user's profile using the contactor IP. The extracted attributes are saved to the resulting metavertex. The extracted attributes include processing of the following information: user's city, country, education, spoken language, subscriptions, various counters such as audio and video files, friends, and so on. The process of analyzing the user's profile photo consisted of several stages, such as fetch the user's profile photos, find exactly one face in the picture, determine the head pose, make sure that the photo does not have inappropriate content, prepare the photo for including into the video. It was extremely important in this project that the human's head has been directed straight to the camera. A person has been looking straight because the final video is dependent on this fact. If everything is determined correctly in the previous steps, then a photo is transferred to NSFW analysis using the AWS recognition platform. However, it has limitations. In our servers, a face is cut out from a photo but the service allows us to find inappropriate content on the entire photo. Therefore, artificially made, for example in Photoshop, incorrect photos can still be allowed by the system. The purpose of the post-analysis model is to extract Holland dominant code for a given user based on the user's posts. The Holland codes model, or ISEC model, is widely used in psychology. Codes are labeled as realistic, investigative, artistic, social, enterprising, and conventional. We pose the problem of determining Holland's codes as a regression problem. The output of the neural network are the weights for each Holland's code for a given user. To determine the dominant Holland code, it is sufficient to take the code with maximum weight. However, as the photo analysis model is used to correct weights, all the resulting weights for the post-analysis model are saved into the storage. The purpose of the photo analysis model is to determine the number of photos that contain different objects. The model is an experimental one and is used to correct the Holland code weights based on the subject of the photo. Consider an example of a correction rule. If most of the user's photos show animals, multiply the weight of code social by the correction factor 1.2. The COCO dataset was used for model implementation. Currently, most object detection algorithms have models that are pre-trained on this dataset. When implementing the model, we experimented with algorithms mask-RCNN and YOLO version 3. In our case, the mask-RCNN algorithm worked about 3 times longer than the YOLO algorithm. The quality of algorithms was comparable. Therefore, the YOLO algorithm was used to solve the problem. The default values of the Holland codes are provided by the post-analysis model. The dominant Holland code is determined after applying correction rules. The purpose of the video creation model is to render the result video file personalized for a particular user. As an input, it accepts a username, aggregated data, and a prepared profile picture. These data are passed to the render process, which renders an Adobe After Effects project by substituting corresponding layers and composition with proper text and image, and the output file is uploaded back to the user. In order to make the final video as personalized as possible, we were faced with a difficult task: to cut out the user's face from the most successful profile photo, adjust the position of the face based on the previously obtained rotation data, and merge the resulting one with the frame on which the actor's photo is located. It became clear that cutting out a face from a photo and completely transferring it to the frame so that it looked realistic would not work. Therefore, we decided to apply a method of mixing the original face of the actor and the face of the user segmented in the photo. Due to the use of this method, in the current version of the system, faces look more realistic than in earlier experiments. In conclusion, let's sum up the results. The developed practical system uses a combination of well-known machine learning methods. Using the HEAS approach allows us to define the overall architecture of the system. Models that use machine learning belongs to the system subconsciousness. A proposed approach allows us to develop a personalized video advertising system based on social network user data. Thank you for your attention.